So let's talk about brain-computer interfaces, the bridge between human and machine. So first things first, what exactly is a BCI? Well, brain-computer interfaces, otherwise known as BCIs, are technological devices that send and receive signals to and from the brain from an external device. It's basically a communication device between your brain and a computer, hence the interface part of the name. This connection is a two-way link, making these machines bi-directional interfaces. I will be talking exclusively about active BCIs, where the user performs a mental task that is then translated to a command within the BCI. The BCI uses electrodes placed on or in the head to send brain activity information to a computer. The computer then translates this information into commands, and the output commands from the BCI can include a number of different things. The process can then repeat itself. So the output commands from BCI can include anything from moving a cursor on a screen to controlling prosthetic limbs to maintaining EEG signals that help control epileptic seizures. Basically, BCIs encompass a very, very broad array of fields. In order to see how these interface devices became so widely used, let's talk about how BCIs evolved into what they are today to see why they are such versatile machines. So the earliest use of a brain-computer interface was worked on by German physiologist and psychiatrist Hans Berger. He is the scientist who invented the first EEG machine, which was the first device that was able to actually record EEG signals. And by the way, EEG simply stands for this long word that I won't try to pronounce, and EEG is just a device that can detect and record the electrical signals from your brain using small electrodes that I mentioned earlier. It comes up a lot, so I'll just refer to it by the shortened EEG. Anyways, Berger is known for recording the first ever human EEG brainwaves all the way back in 1924. But it wasn't until later, in 1977, that the actual term was coined by this man, Professor Jacques Vidal. Vidal is also the one officially credited with the invention of these brain-computer interfaces because of his publications. In his publication in 1977, Vidal had his first successful experiment using a BCI. This experiment consisted of using the EEG signals that Berger researched to actually move a cursor on a monitor screen. It was a major breakthrough in the use of BCI technology. 11 years later, in 1888, a group of scientists, whose names I will also not be able to pronounce without embarrassing myself, conducted another laboratory experiment using BCI and EEG signals to control a robot. They were able to direct a robot to follow a line drawn on the floor by sending these brain signals from an EEG machine to software connected to a BCI. Scientists were now able to control physical objects by the use of brain power alone. A decade later, scientists Philip Kennedy and Roy BK were able to implant the first ever BCI into the brain to retrieve better quality signals from subjects to produce more accurate computer commands. And today, we are able to use BCI technology to do things like have a quadriplegic man drive an F1 car using only his brainwaves. We can increase motor skills with the aid of robotic prosthetics. We can activate a response in a patient's muscles. We can control a computer interface in order to type or speak, or even just play really immersive video games. So there's a lot of different types of brain-computer interfaces, but the most interesting area to look at is in the field of medicine. So there are 3 different types of BCI machines based on where or in the head they are placed. First, you have the non-invasive BCIs, which look kind of like a swimmer's cap placed over the scalp of a subject. These machines can measure either the electrical potential using EEGs or even the magnetic field, since both belong to the study of electromagnetism and are therefore very closely related to each other. The electrodes in these devices are placed the furthest away from the brain, so the data collected from the brain waves can be very small, from a weak signal, or simply inaccurate. The second type is semi-invasive BCIs. This is where the electrodes from the BCI are placed directly on the surface of the brain. Yes, it does require surgery so it's usually only used for medical purposes. This method for recording brainwaves inside the skull is called electrocorticography, or ECOG for short. Now, if that doesn't sound thrilling enough, there is a third kind of BCI, called invasive BCI. This is where the electrodes are placed directly on the brain's cortex and can measure the activity of a single neuron with notable accuracy. Since the operation to place an invasive BCI is the most risky, the procedure is used in only the most severe of medical cases, namely for those who are blind or paralyzed. The BCIs I will talk about will mostly be either semi-invasive or invasive because of their medical applications. I've already listed a few different examples of the many applications that BCIs have within the medical field already, but let's look at the largest areas of current research. Professor Johannes Kogel and his team described the purpose of using BCI technology as a way to restore or increase communication and motor skills for persons with physical impairments, improve rehabilitation for persons who have had a stroke or spinal cord injury, and help to regulate or treat persons with psychiatric conditions or epilepsy. And in a Mayo Clinic paper from 2012, Dr. J.J. Shi stated that the main goal of BCI is to replace or restore useful function to people disabled by neuromuscular disorders. Basically, there is a threefold application of using BCIs. For those who no longer have use of a limb, or require assistive devices to interact with the environment around them, or those who are unable to speak. Through the aid of doctors and scientists, patients are able to rehabilitate in order to navigate through their everyday lives. If you have a motor disability, there are BCIs that can enable you to move around more independently and even control other objects around you. If you have a prosthetic, it can be controlled by a BCI to act more like a real limb. If you are recovering from a stroke or suffer from epileptic seizures, there's also a BCI machine for you. However, as there is with any technological advancement, there is always a question of ethics. Is the technology being used safe? Does it at any point take advantage of patients with disabilities? And what are the logical limitations to using BCIs in the medical arena? These are all questions that need to be asked and answered, and these issues usually fall into categories concerning safety, autonomy, responsibility, accountability, psychosocial identity, consent, privacy, and data security. For example, BCIs use software that is communicated back and forth between 2 points, and like all data, it is subject to be stolen and used for criminal purposes. This leads to a question of privacy, since the signals being used and the data being shared can potentially be used to gain information about the person using the BCI. But even with all these different types of questions about how the data is stored or how to make sure that it is protected, there's surprisingly little information from scientists about this topic on ethics. Not much actual research has been done that evaluates empirical data. It seems that scientists don't have much to contribute to the conversation about the philosophical or even psychosocial aspects of using BCI technology. All we really have to go off is what the users themselves say about the technology that they are participating in, and how they feel about the different concerns presented to them. And even though it is a subjective perspective, the common denominator between all those who have been interviewed is that the potential benefits of using BCIs outweighs the potential risks that go along with it. It's clear that patients using BCIs are optimistic, as they should be when participating in medical advancements, but not much is known about the long-term effects of using BCI technologies. The future is bright for brain-computer interfaces, and scientists are only limited to what their brain power can supply. From driving cars to working computers, BCIs have made a tremendous difference in the lives of disabled patients who have had the opportunity to use this technology to regain a sense of autonomy. And BCIs, brain-computer interfaces, are not going anywhere in the near future.